Thank you again, Drew, for presenting today and for supporting the Red Team Village and Texas Cyber. And without any further ado, welcome and take it away.
Thanks so much. Good morning or good afternoon, wherever you are. I'm excited to be with you today virtually and share how you can detect complex code patterns using semantic grep. So the one-slide summary of this talk is it's really hard to write secure, robust code. Static analysis is a powerful tool, but it's often too noisy or too slow, and we need more flexible open source tools. Enter Semgrep. But before we dive into all that, let me introduce myself. So I'm Drew. I'm one of the co-founders of R2C, and R2C is a new static analysis startup that's passionate about building tools for security engineers and developers to help write more secure software everywhere. A quick outline of the talk is I'm going to go through some background about about Semgrep and what the tool is, and then we'll talk about some prior art with grep and abstract syntax tree, and just talk a little bit about the problem. And then we'll dive right into doing some pair programming so you can see how easy it is to use the tool. And then finally, we'll talk about going beyond what we showed today and next steps. So to get started, you just go to semgrep.dev if you'd like to follow along. That's just a quick redirect to our GitHub project, and you can read the instructions and the README how to get it set up on Mac or Linux there. But just remember, yeah, semgrep.dev, that'll take you to our open source project. So Semgrep is not completely new. It was written in 2009 at Facebook by Johan Patalu, who was the first program analysis hire at Facebook. And they used it to search code and also enforce kind of invariants or best practices in their code base. Last year, we were really excited to hire Johan full-time, and he's been working to improve the breadth and depth of Semgrep. So you might be asking, does Semgrep work for my language? We've added many languages in the last couple months. Right now, we have really good support for 5 languages, and we have 4 more coming this month. And we also recently added support for JSON, so you can start to search configuration files and the like. Again, Semgrep is open source, it's LGPL licensed, so you can use it for commercial use, you can modify it. Really nice to have a permissive license, a great security tool. So I love grep, and grep is probably the most common used way to search code. It's very trusty, I know it, I use it all the time, and it's probably the first thing I'm going to do if you ask me to audit a code base, right? I'm just going to look for, show me all the routes in the code base, look for any hard-coded strings, who are the authors. But there's a little bit of a mismatch. So, if you're trying to solve every single problem with a regular expression, it's going to become pretty unwieldy fast, and you'll start to realize the complexity as we dig into it a little bit more. So what's going on? Well, even though we all write code as a string, and you often think of it that way, to a computer, it's not just a sequence of characters. There's actual semantic meaning and structure. And the first thing a compiler or an interpreter will do is it will lift it into a tree structure. And this is known in the industry as an abstract syntax tree. That's not super important, but the thing to remember is that that we're losing all the information that the computer has, function declarations, decorators, arguments, if you just treat code as a string. And so that's one reason why grep is maybe not the best tool if we're trying to do precise matching and have low false positive tooling. So let's talk about how we would search code as a tree. You may not have thought about it too much, but you almost certainly are using some tree matching tools every day. If you've ever used a tool like GoSec, GoLint, Bandit, DLint, Flake8, ESLint, any of these linting infrastructure tools, you'll typically be operating at the tree level. And so that's great. But if I'm going to be a security engineer and I want to audit some code base, I'm probably not going to go and say, let me write a new GoSec plugin. That would be really cool and be awesome to ship. But the one challenge is I have to be an expert in every single syntax for every AST, and each language usually has its own built-in AST. And oftentimes you need to understand kind of the ins and outs of the programming language because there are oftentimes many different ways to do the same thing. And usually you have to think about it more as a graph search problem because you're working over a tree. And so that's great, but you kind of have to step out of the context of what are you trying to actually search for if you're a security engineer. There's some commercial static analysis tools, and they're great, but they can often be very slow because they're trying to do a lot of things, and they may not be open source. They might be expensive, and so we'll kind of not consider those as part of the scope of this talk. But also, just to give you an example of, if you think about having to write a typical AST tree matcher, it's usually not the easiest thing to write. I started writing these last year, and I was looking at the source code right before this talk for the way ESLint looks for no eval in JavaScript, which of course is like the most simple. Like nobody should be using eval. Plenty of security issues. But that takes over 300 lines of code just to find, all the different ways people can call eval. And so again, it's not something I'm going to just reach for when I want to do a quick check. I'm definitely going to turn to grep. Last year, there was a great blog post by the Instagram engineering team where they talked about kind of the spectrum of tools that we can use in our toolbox when we want to look at code. So we have, regex-based linters, effectively grep. That's pretty cool. Very fast, very easy to use and easy to get started, but it doesn't, understand the structure of the program. And then, of course, they have, whole program analysis, type checkers, kind of the classic, like deep program analysis, understanding. And that's some of the tools that, folks at Instagram are writing. And those are really powerful. They're very complex, and they're kind of, they were making the case that there's a middle ground, which you have these AST-based lints. And that's the area that Semgrep really excels in. So let's jump right into a demo. I'm going to go through 3 different sections. We'll talk about the syntax of Semgrep, a couple different operators you need to learn, and then we'll dive into some like anti-patterns and business logic, and then finally we'll cover some advanced features. So let's take the simple case. We're going to have some JavaScript code. We're going to be looking for calls to exec. Exec is going to call out to the system libraries. In this case, we're going to be calling ls. And you can use Semgrep on your command line terminal. There's many different ways you can run it. You can run it as a Docker program. But we also have a live editor, and that's running at semgrep.live. And so I'm going to hop out of the presentation right now and jump into the live editor so we can interactively write it. It's just really easy to use from the demo perspective. So if you've ever used a tool like regex 101 or some of these online editors, this will be familiar. Let me just kind of quickly talk you through what's going on. So in the top, we have where we're going to write our pattern of what we're trying to find. Down below it, we have some code snippets that I've pasted in. But you can choose many languages, and you can actually load the snippet from a random URL. So anyways, it's pretty easy to just paste in what you're trying to find in the lower right. And then on the right-hand side, we have all of our matches that will show up. And there's some basic documentation if there are no matches. So let's get started. We've got 4 different cases of exec. And if you kind of think through how you would search for this with grep, you're like, that's pretty straightforward. I would just search for exec and then maybe open parenthesis. And that will work pretty well. But there's a couple cases you have to think about. So you might have multi-line comments or functions because you're using a formatter, or the way the program has decided to structure their code might span multiple lines. You might have arbitrary little white space, and some languages like Python, white space doesn't matter. You might have commented out code. You might have things like a string inside a logger. And so if I just search for exec, I'm going to hit all of these cases, and I'm going to have to look through all of them. And what I'd like to do is just find the actual function calls. And so what I'm going to do is I'm going to copy and paste code. And this is going to be something you're going to see me do a lot throughout the day in the talk. So let's just copy and paste the code. Now this will match exactly what the first line is, but I don't care about just that specific case. I want all calls to exec. And so this, let me introduce the first operator we have. The first operator is the ellipsis operator, and it's just indicated by 3 dots. And this is something similar to like dot star in regex, where you're just saying, I don't care. There can be 0, there can be 1, there can be 100 arguments to exec. Let's just match all of it. And so now I'm going to search for exec calls, and if I just click run, it takes a little bit under half a second, and it will find the 4 cases we were hoping to find. So under the hood, because what Semgrep is doing is it's parsing the pattern and it's parsing the code snippet into a tree, and then it's doing a bit of a fancy diff algorithm to find all the places where it matches. It automatically takes care of all the different semantic parts of the language that you don't have to care about if you're just a security auditor looking through some code trying to find vulnerabilities. Great. So let's go to the next case. And here we're going to introduce a second concept, which is the concept of variables. And you'll notice that because Semgrep works across many languages, I'm going to demo and switch between different languages. So in this case, we're going to look through some Go code. And in Go, if you're not familiar, there's an unsafe package that basically escapes the type checking and a lot of the other nice parts of Go, where you can get rid of a lot of the bugs you'd find in C. And so as a security engineer, one of the first things I'm going to do is look for all calls to unsafe functions and just start to do a manual audit based on that. So if we load up this example in our live editor, and maybe I can just zoom in one, that's a little bit easier to see. So here now we have some Go code, and this is a little bit more of a larger program. I have some imports, I have a main function, and what I'm going to do is I'm going to look for all calls to the unsafe pointer. And so I'm just going to copy this code, and we'll use our ellipsis operator that we learned about in the last pattern, saying we don't care what the arguments are. But now I'm not sure that I want to find just calls to pointer. Maybe I want to find any function that's inside that module. And so I'm going to have unsafe, and then I'm just going to do $, and then just capital letters to define that is now a variable. And so as we do our matching, we'll match any function call inside the unsafe package. And so you'll see there's a couple different cases here. I have unsafe pointer, I have unsafe size of, different variables. And so if we run that, you can see we correctly match the 3 different cases. And so now it's pretty straightforward to see how you can write a pattern using a combination of variable functions as well as ... And I don't know, Omar, if you're seeing the squiggly line over trace, if that's part of Zoom. Hopefully that's coming through. But let me move on to the next.
It is coming through.
Okay, great. Is there a way to clear that?
I think it's your annotations. You probably click on annotations there.
Okay.
Let me try.
Let me see if I can just clear that out. Let's see, clear. I have cleared my annotations. There we go. Perfect.
All right.
And let's see if I can go back to the mouse. Thank you. Sorry for the Zoom mistake. Now let's talk about another classic security problem. And so here you have calls to a function where you're going to have user data. And this is classically known as an injection vulnerability. So we have some data that's controllable by the user. In this case, we have file name, which can be defined by the path that the user is going to be calling. This is a Python web framework called Flask, but it would be pretty common across any sort of web server where you have data that's controllable by the user. And then that's going to get passed to what's called like a dangerous function. And so in this case, we have send file. And what send file does is it just reads the file from the file system and sends it down. And so you could immediately see how this could be dangerous if someone says, hey, my file name is ... /... etc password, or some other sensitive file. And so this will build on the last example where we have variables. We're going to use the variables to actually track how they flow through the program. And this is really powerful because it lets us look at a couple different cases. So here I have 2 routes in my simple Hello World Flask app. And the first one is an index file, and that's just going to always serve index.html. That's not vulnerable. I don't want to just search for send file. I want to find all cases where calls to send file is happening and it's user controllable. So let's do what we did in the past. We'll copy and paste. So now I'll just go through this line by line with you and talk about how I can abstract this away and turn it into a useful pattern. So the first thing is, I don't care about the specific of the route. I want to find all routes. So I'm going to go ahead and use 3 dots. And there's actually a way you can use a regex here if you read the documentation. So maybe you just want to search a specific folder inside your web application. That's possible. And then we'll abstract away the function. So I'll just define that as function. Doesn't matter what I call it, but I'm just going to say, and then I'm going to do something like file name. And so file name now is the variable that we know is sort of unsafe. User can control that. And then I'm going to use my ellipsis operator. And this will show that the ellipsis operator doesn't have to be used just for a sequence of characters. or function arguments. It can also be used to abstract away entire statements inside the program. So if there's 5 lines or 10 lines between where the function is defined and where it's used, that's fine. The ... will extract all that away. Next, I don't want to call find all calls just to send file. That might be a locally defined function. So if you see on line 1 in the Python code, it's actually being imported. And so we're going to pull that in from the Flask package. And so we're going to look for calls to Flask send file. And then here I'm going to reuse that same variable I defined above and say, okay, that's user controllable. And then I don't care about the rest of the arguments. So I'm going to use my ellipsis operator with 3 dots. And so now this pattern is generic, and it looks for calls with user controllable data into this dangerous function. If we run that, now we can see we correctly match only the case we care about that's insecure, and we don't have any false positives with the secure case. Now let's look at another common security problem, which is when you're dealing with cookies. So I was surprised to learn when I was looking through some of the documentation for the Flask framework that cookies by default are not secure. They're not HTTP only. So they're accessible to JavaScript, things like that. They're just kind of out of the box. And so if I'm a brand new developer who's not familiar with the security sharp edges of the framework, I'm probably going to write some code that looks like this. I'm going to say response.setCookie, username, Drew Dennison, right? That's my name, and I can just identify the user with some code like that. Of course, I'm probably going to make it a little bit more complex. I'm probably going to have an inner function that actually generates the cookie value. Maybe it's a unique ID. I might set a couple flags on the cookie. And so again, if you're thinking about how am I going to search for calls to setCookie, you have to consider multiple lines. You have to consider different inner functions. You have to consider commented out code. And lastly, we have the case where this is actually best practice or secure. So in this case, I've set a value and then I've defined secure as true. And secure just means that it will only be sent over SSL connections. And so if you're not familiar with cookie vulnerabilities, oftentimes people talk about being on insecure Wi-Fi at a Starbucks and someone's sniffing their cookies. It's because someone didn't have secure as true and they visited a non-HTTPS link, and so the cookie value was exposed. And then kind of best practices, you should set HTTP only as true, which means that JavaScript, they might get injected or might be untrusted. Advertising code can't just read your cookies and ship it off somewhere. The browser is going to enforce that only that page can use it, send it. And then finally, there's a new setting on the cookie, I guess, that's called same site. And so that will determine, which request it gets sent with. And so lax, I think, is the default that is recommended these days. So again, we want to basically match line 8 as well as lines 13 through 15, and then not match the cases where we have commented out code or the secure case. And so I'm going to do a new concept here, which is basically advanced pattern composition using a YAML syntax, but it's pretty straightforward. And so we have a couple things here. So first thing we have is an ID for the rule. So I'm just going to call it Flask secure cookie. And this is just useful if I want to kind of reference this later, give it a friendly name. And then the next thing was we have a pattern key. So this lets me do some basic Boolean logic. If I was using grep, I'd probably do grep-v to say exclude the cases that are secure. I don't care about that. And then everything else will match this pattern. And so I want to match that. So let's look at what we would need to do here. So the first thing is the secure case. We have flask.response.setCookie. And that's just imported above. It's also being, you'll notice that it's defined as response, but it's imported as R. So if I'm searching through this with grep, I have to understand okay, the developer might have aliased this. So in this case, we will correctly resolve that and understand, okay, it's part of the Flask response object. So that's great. Then I don't care about the arguments. Those are kind of the first two cases are just part of the cookie key value syntax. But what I do care about is looking for things like HTTP only is true and secure is true. And I won't worry about the same site because that's maybe a newer function. But if you're looking closely, you'll notice that the order of these keyword arguments in Python doesn't matter. And so here in this case, I have HTTP only is true as first and then secure. And down in this example, I have secure first. And semantically, it doesn't make any difference to the program because it all gets turned into a dictionary. But if you're having to think about how would I grep for this, it's another edge case you have to consider. Okay, great. So now we have the case we we don't want to match. Let's just grab everything else then, and we'll say that's probably insecure. It's at least worth a look, and I'd probably want to audit it in the code base, or maybe I can find a vulnerability in an open source package. And then finally, I'm going to give it a message. So this might just be like, hey, cookies are difficult to do securely. So you can give anything you want here. And if you defined a variable above, you can also put that variable in the message, and that will get populated. And I'll show that in another demo. But just, yeah, it's easy to give a friendly little message. There's also support for a metadata key. So you could tag it as like, okay, this is part of my red team collection, something like that. But anyway, it's pretty straightforward. A couple lines of code. And I've now combined this Boolean composition to understand, let's just find the insecure cases. Well, let's try to run that. So if I did everything right, yep, we got the two cases we were looking for, kind of the naive case. I just called setCookie without any flags, as well as this multi-line inner function with one flag set. I correctly did not find the two cases that I don't care about. Awesome. So that's just a very fast overview of the three main concepts you need to learn in Semgrep. One, you have these ellipsis operators, and then the meta variables, and then finally how you can combine it with simple YAML syntax to get the power and flexibility of both. Now let's dive into a couple other cases. So we have anti-patterns, and this one's just a little bit of fun. It shows you that you don't have to use Semgrep just for security problems. But if you think about the case where someone is searching for foo equal to foo, that's naively always going to be true because you're comparing something against itself. And so you can kind of say, hey, it's an anti-pattern. It's probably a typo that the developer made when they were writing this code. Maybe you want to alert that to them. So I'm going to pull up the live editor again. And here you can see, I won't write the code because it's super simple. You could imagine, how would I find cases where I have foo equal to foo? Well, it's really straightforward. I can just say $x equal to $x, and that will enforce the equality constraint on both sides of the operator, and it will kind of abstract away all the complexities. I can work with strings, integers, variables, but it's going to say that same part of the code is being compared to itself, and so we want to flag it. This is pretty cool. I mean, it's a pretty trivial bit of code. Let's see if anyone's ever made this mistake in a real code base. So if I pull this up here, I'm going to search for Apache libcloud. And the first thing I'm going to do is just paste this into this little scan get repo URL. And so there's a little bit of busyness on this page, but basically I can see prior scans. I can see all the code in my GitHub org, and I can scan an arbitrary get URL. In this case, I'm going to search Apache's libcloud, which is a library that kind of abstracts away different clouds and tries to normalize those. And so if we scan it, this will take a second or two, but it just ran like that. And I can jump into this project, and I'm surprised to see that there is a case where someone has $x equal to $x. What's going on here? And so if we look at one of the drivers for Cloud Sigma, which probably isn't one of the most popular things, we can open that up though and see if this is indeed a real bug. And so if I zoom in here, you'll see that there's this inner function called getNode. And what it does is it just looks for the list of nodes, and then it filters it down by this node ID, and then it tries to return the first one. Pretty straightforward, but you'll notice on line 615, if I understand the code correctly, they are searching for all the nodes, looking for node ID equal to node ID, which is always going to be true, and so you'll get just an arbitrary, the very first element in this list of nodes rather than the one you're actually trying to find. So this looks like indeed it's a real bug. The developer probably meant to type node underscore ID, but maybe their editor auto-completed to node.id. And so this is just one of those like, yeah, we should definitely alert this. It'd be great, it'd be helpful to flag and see if this is a real bug. Maybe there's some security implications if you're searching like JWT tokens and you're looking for something that's being compared to a different one when you actually meant to compare it, being compared to itself instead of a different one. So that's an example of a really interesting anti-pattern that we can find now that we have the power of semantic grep. And of course, you can imagine many other anti-patterns you could express. Next, let's talk about one thing that would be really difficult to do with commercial static analysis tools or linters, which is oftentimes the security bugs are kind of subtle. You have to read through and understand, what was the mindset that the programmer had when they were writing the code. And so in this case, I have a fictional financial trading application where the developer has made the design decision where you have to call verify transaction on every transaction before you make it committed to the database. And so if you forget to call verify transaction, that's going to be a security issue. The bank might lose money. And so no tool out of the box is going to just have this. I'd have to kind of manually read through all the code, and who's got time for that? To do that every single day on every single commit. We need better tooling. Let's jump into the case here where I'm going to look for unverified transactions. So in this case, it's a little bit busier. I've copied in a slightly longer pattern, but the overall structure is not anything new. We've just talked about this. So we have an ID. We're going to find calls to unverified transactions. And then we're going to look for any function with any method, with any arguments, with any statements. We're going to alert on any calls to make transaction that don't have verify transaction called before them somewhere in the order of operations inside the control flow. And then I've got a nice little message that I'm going to pass out to the user that says, hey, in this method, you should do this. And so if we then look through some example test cases, I have, again, a little bit of Go code, and I have a couple cases. So I've got a main function. I've got a case that is correct. So this is verifying the transaction, and then it's making it. So that's great. In this case, I've forgotten to call verify on it. So that would be a vulnerability that we need to go address. In this case, we've maybe copy and pasted some code wrong, and so the order is backwards. And so I'm making the transaction before I'm verifying it. That's not great. And then here I'm just like verifying it, so that's fine because there's no issues there. And then finally, we have a case here that I want to talk about, which is where I'm verifying this transaction T, but then I'm verifying this other transaction, but then I'm making this transaction T. And so that's a problem because now we think we're secure. The developer is like, hey, I called verify, but then I made a different one. And so if you imagine trying to solve this problem with grep or some other simple find tool, you're probably going to say, oh, okay, like a couple lines away from it, inside those kind of context lines, I see that they called verify, so it's probably safe. And in reality, you're going to miss it because you're not actually following the data as it's flowing through the program. So we have to do a little bit of tweaking to our pattern here. So if you notice, we didn't flag this. We should have flagged it. And that's because we are just looking for any call to verify transaction before any call to make transaction, and we're not enforcing any constraints. So I'm just going to define a variable here as $T for transaction. And then I'm going to go through and do the same thing and use that variable. And so now I've correctly enforced that calls to verify are done on the same transaction before they're made. And so if I run that, zoom back out here for a second, now you can see I've correctly flagged this additional case where the calls to verify on the other transaction is now flagged. And so that's just an example to kind of show you. It's like 10 lines of code, a couple simple patterns. It looks and feels just like the code that I'm trying to find, so I don't have to switch context. I can just copy and paste the code and replace a few things with some dots and some variables. And then I have a fully kind of written lint rule that I could start to imagine using to scan my code base and find these really interesting subtle security bugs. All right, let's get on to some advanced features. So the next thing, when I'm auditing a program, one of the main things I would often do is look for all the places where a user can control data. And so in a web application, that's typically a route handler. I could imagine searching for it, but now that I have Semgrep, it could be really straightforward to look for all route handlers using Semgrep. So let's see how we would do that. So in this case, we have some Go Gorilla code, and that is a popular web framework for Go. And I'll just show you, you import it here, and then you basically define a couple different route handlers. And so the first thing you're doing is you're saying, okay, for slash products or product, or there's regex, whatever, we're going to call this function inside our app called get product or update product, and you can define the methods. So pretty straightforward. Looks like 99% of web apps. We want to go through and try to audit all these places. And so again, we're going to copy and paste some code. And so what I'm going to do here is we're going to paste this line, and then we'll just go through and replace tokens with variables as we want. So the first thing I'm going to do is, this is our app. We don't necessarily know what that is. We know there's a router. We know there's a handle function. And then we have a route. So define route. And then we have a handler function. And so again, this is going to be something that we will be responsible for. And then finally, we have an HTTP verb, in case like get or post. And so I'm going to also say verb. Awesome. Now I have this. Let's see if we can run it. It should match all the cases we care about. That's awesome. But the message is still saying to do. And remember, like, what I'm trying to do is I'm going to do some post-processing with it later. Maybe look through it in Excel or a different tool. And so what I want to do is extract all the parts of the code that I care about. In this case, I have route, handler, and verb. And of course, you can put whatever message you want here, but I just want a CSV of all these data. And so I'm going to put that like that. And then if I run it, now you'll notice that we've extracted the relevant bits of context from these route functions, just like we would with a capture group, but we're doing it again semantically. And so in this case, we have product, products, and then the handler function and the verb. And so that's an example of how I can use Semgrep more as a library, as just one part of my tool chain. And what I did with that afterwards is I put together a visualization. And so this is, I don't know if you can see, but it doesn't really matter too much, but this is a D3 tree visualization of all the routes in this pretty complex application, and it's color-coded based on if it's an admin required route or if it's unauthenticated, things like that. So now I can just use Semgrep as a way to sort of lift things out into context and then build other tools on top of that. Finally, let's talk about fixing code. So it's great to find vulnerabilities and awesome to get some hacker cred, but really we want to kind of be helpful and give back to our friends who are writing the code. And so maybe it's our own project, and we're like, hey, wouldn't you just auto fix this for me? Oftentimes you can if it's super simple. So again, I have a fairly complex example, and this is actually one we have that has a bunch of metadata, and it talks about CWE numbers and OWASP categories. So it's a little bit busy, but let's kind of see if we can use the same pattern to sort of talk through what's going on. So again, this is literally a hello world app, and we have a handler just like we did in the previous one, and we're going to go through and serve on port 80, and there's a handler function here that's nil. But I want to just audit all calls to HTTP listen and serve, which is sort of the development web server. It doesn't do any encryption, it doesn't do any SSL. And so, often developers will have a develop server and then forget to remove it in production. And so if I'm a security engineer, the first thing I need to do is look for some of these like really simple, someone left the debugger on, someone has an unencrypted server. Let's see if we can find all calls to that. In this case, I have the address. That's just going to be port 80, it could be port 443, it could be port 8000, doesn't really matter. And then I have the handler. So if I run that, great, we found the case, like that's my security audit workflow, and that worked quite well. But we want to talk about how we could actually fix this. And so here we have this new fix key, and what I can do is I can copy this, and if I am familiar with Go, first thing I'll realize is there's actually a listen and serve TLS, which is the correct function. But then I can't completely auto fix it because you also have to define the cipher, and you also have to give it a key file. And so here I have something that needs a little bit of intelligence from the developer to actually choose the cipher. Maybe I do know the cipher. Maybe it's let's just say SHA-256. I can start to go through and define different parts of it, and then other parts obviously you'll have to go through and fill out later. But if I want to be helpful, now if I run this pattern, you'll see in the live editor as well as on the command line tool, there's an auto fix suggestion, which says, hey, this part of the code I found, we think we could replace it. It would look like this. And so if I just click apply fix, now we've gone through and we replaced it. We've picked our cipher algorithm. We've given it our key file. And so of course this code won't compile because key file will be undefined, but now we could make a patch back and say, hey, you guys have to fix this up, add a key file, and then it's secure. So that's a really quick example of how you can use the same syntax we just talked about using code, pattern that looks just like code with a variable, and then how you can mutate that as a fix and then apply that to your code base. Next, maybe there's some logic that we need that is not quite expressible by Semgrep. In this case, I'm looking for insufficient RSA key sizes. I think the recommendation is to use 2048 and nothing below that. So again, I can quickly write a pattern that's just like generate key, but I want to actually do some logic on top of the key size variable. And so let's see how we can do that. In this case, I have a fully written pattern, but if we look at the relevant bits here, so we're using pattern, and we're going to use Semgrep to extract out the number of bits. So in this case, I'm calling RSA generate key, some arguments, it doesn't matter. We know the last argument is the number of bits. And then I'm going to use this special patternware Python that has to be waitlisted just for security reasons, because we are executing arbitrary Python, but we're going to go and read the number of bits out of our variables, and then we're going to cast that to an integer, and we're going to flag any case where it's less than 2048. And so now I get basically this nice composition where Semgrep gets to do the part it's really good at, which is understanding the code and kind of zooming into the relevant bits. And then I can use any arbitrary logic I want in Python, and you can do multiple lines, and that all works really nicely. And so here, just to prove it works, it doesn't fire now on this 2048, but it will correctly flag the insufficient number of random bits in the 1024 case. And so now we have a nice message that says, hey, RSA key should be at least 2048. And you can imagine how this would be useful in both an auditing or like a kind of an enforcement context. So I know there's a lot of different operators, and I quickly covered a couple of them, but the documentation has full support for the various different syntaxes. And so we have support for pattern, pattern not, pattern either. You can actually combine both regexes and Semgrep patterns with pattern regex. And then there's a bunch of different things. Go read our documentation. But just to give you an example of how it's flexible and powerful, you can do that inside the simple YAML syntax. So a lot happened. I showed a bunch of different examples we pair programmed together. Maybe we kind of zoned out for that. So let's do a quick recap, aka can you learn Semgrep in 5 minutes? Yes. So the first thing is we're doing code equivalences in the semantic where search pattern. And then there's a couple different things you have to realize. So if you look for $X, that's going to match any expression of characters, syntax, statements, expressions, and we're going to enforce that across multiple languages. And Semgrep is going to go through and understand the semantics of the language. So it knows that A plus B is not equal to A plus B is also equivalent to not A plus B equal to A plus B. And so it's going to extract away the complexities and the different ways you could do things by just saying, what are I trying to express as a human? Hey, I'm looking for $X equal to $X. In the same case, in certain languages, you have these keyword arguments where the order doesn't matter. Semgrep's going to be smart enough to understand, okay, the ordering doesn't matter. It's semantically the same. And there also might be multiple ways to import something. So you have like from subprocess import open as s.open, and you can just write a pattern like subprocess.open, and Semgrep will do the full resolution, look through all the different constants, and realize, okay, that's actually the same thing. I should flag there. Similarly, there's multiple ways to import things. So we have import foo.bar is semantically the same as from foo import bar, and so Semgrep knows about these language specifics. So you don't have to do that, and you can just focus on the pattern you're trying to find. Next, we talked about the ellipsis operator. And again, this just abstracts away entire sequences of characters or expressions or statements. And so if I want to find all calls to foo, the last argument is 5. I can use ... to say, yep, match that one case where there's just 5, as well as cases where there are multiple arguments. You can do the same thing with strings, and you can also get rid of multiple statements like print statements and other things. And so the ... ellipsis operator is really powerful. Next, we talked about meta variables. So meta variables, again, are just $ with capital letters. And you can just say, okay, I want to abstract this part of the program. It can be a single variable. It could be an entire expression, like an if statement, or it could be a function call, things like that. So again, it's just useful to pull those things out, and it helps you match. When you say I want to match things that have exactly 2 arguments, you could do $x, comma $y, and maybe that's a little bit more constrained than just using ... Next, because Semgrep understands the kind of the relationship, you can actually compare the equality or the the values of these meta variables and say that pattern has to look exactly like this. And so again, we can do things like, okay, this call to open is then not being passed to a close function. That would be a bug, or other different security issues like injection attacks. So that's a real quick summary of the 3 main concepts to understand in Semgrep. Again, we have semantic matching, we have the ellipsis operator, and finally we have meta variables. So we started writing a bunch of patterns. It was really easy. We found we could write like 25 patterns in a week, and we realized quickly that managing all these patterns was getting complex. And so we started writing a registry. And we have a registry. It's on our live editor. I'll show that in a second. But that also just loads from a Git repo. And so this is open source. Anyone can contribute or consume from this registry. And it's because it's just YAML files. It's really easy to just have this as a pattern. And so I think last time I looked, we have over 400 rules in our registry. And if you want to get started and use the registry, you can just do brew install Semgrep. And then Semgrep takes a config argument. It can be a registry or a folder of YAML files. Really straightforward. But it can also be an endpoint that serves it. And so that's what our live editor does. If I look at the registry endpoint, this is just a cleaner view of that Git repo of all the rules. And so here you can filter and drill down and say, okay, I have things like I only want to see Python rules. Maybe I only care about security, or I don't care about performance. And then you can just see all these rules. You can click into them and see like, okay, this Python eval function, the pattern looks super straightforward. If I want to edit it, I can pop right into the live editor. I can view it on GitHub. And so you can just see how, okay, cool, I want to copy this. I want to use this. I don't have to be an expert in all the different ways that someone is doing different patterns. And so in this case, we have one of the authors of DLint has contributed all of the rules. And it's just this long file, but I don't have to care about that because someone else is an expert and I can use that. And I just wanted to say that we've already seen really great community participation. So we have hundreds of rules that we've already written ourselves. But we were pleased that the author of Node.js Scan just released version 4, and that's completely powered by Semgrep. We've also been doing a bunch of work porting like GoSec and FindSec bugs into Semgrep. And one interesting thing there is you don't have to fully compile the language. So something like Java, FindSec bugs typically works on built artifacts. Because Semgrep just operates on source code, we can actually copy those rules in and search source, and we don't have to figure out how to build the tool. And then we've got some great rule of contribution ideas from some various open source maintainers. Next, let's talk about integrations. So you're like, I love it. I'm sold. I'm going to use this tool whenever I search through code. But wouldn't it be great if I could actually set this up in my environment? And so we have a couple integrations here. We have an integration doc. We use it as a pre-commit hook as well as a GitHub action. And I'll just quickly show how that looks. So because we're using the GitHub APIs, here we've copied a large PR. We can see like 200 files have changed. But if we actually look through the checks, we're going to use the Git API. So it just says, hey, this Semgrep check on this pull request failed. You can go see the details and kind of exactly why that happens. And we also have the option to set it up with a Slack notification. So this will tell us every time there's an issue. If we don't want to necessarily block the build, we just want to be alerted. That's pretty straightforward. So again, you can look at our GitHub action. And then I want to talk briefly about more features coming soon. So we have user-defined code equivalences that's in beta right now. So I can start to say like, hey, I know in most languages, $x plus y is the same as y plus x via the commutative property. And I can also say like, okay, I know that when I do like file.open, or I want to do like with file open, those are all equivalences. And so I can start to define those as part of our registry as well. And then we're integrating some type information. So in some languages like Go and Java, you have types built in. That's great. That helps improve the precision of the rules by saying, I only want to find calls to like new buffer where there's an integer. And we're also working on support for third-party typers for dynamic languages like Python, Ruby. Please let us know if your language is missing, because we're taking votes for new languages. We're working on an IDE plugin, and actually something that just got done last night. So this is very beta, will be released probably next week. Is I want to show how you can actually say, I have a case here, going back to the set cookie example, but I don't know exactly how to write the pattern. What would that look like? So what you can do is you can actually highlight the bit of code that I'm trying to look for, and I can say generate suggested patterns. And so when that happens, Semgrep in the background will go through and understand kind of all the possible ways you can match this. And it will give you 4 different examples. One is ... one is the exactly, literally hello world, cases where you have X and Y. And so if I just click use, then it will automatically fill in, and it will correctly go through and say, okay, it's Flask response.setCookie. And so I'm really excited about this, because now you can actually look at code, copy it, and automatically generate a pattern, and you don't even have to figure out how to write it yourself. So that, look for more coming there, and that's pretty new, but that will be coming out soon. So finally, I just want to say, again, the Semgrep is an open source community project. Please help us make it better. We have many rules for different frameworks, but we would love your help in writing rules. If you are a security expert in a couple of areas, please talk to us. We have a community Slack. We'd love to help you figure out how to use Semgrep and write the rules. Search for vulnerabilities. And if you want to give me feedback about this talk, you can go to r2c.dev/survey. I'd love your feedback. And if you fill that out, I'll send you a curated list of rules for some OWASP top 10 issues if you want to use it. Please use it to give us feedback. We release every single week, and we're always looking for good bug fixes and sharp edges, things that are confusing. So please tell us about that. And it's pretty easy to contribute rules. So that's probably the easiest way to get started. If you write a rule in the live editor, you can actually click share and get a shareable unique link. You can also contribute right to our registry by just giving it an ID and then publishing it. And then it's part of that Git repo, so anyone else can use it, and you can send it to your friends and they can check it out. So yeah, we'd love your feedback and contributions. Thank you very much. It was awesome being here, and thanks to the organizers for putting on a great event. Again, to get started, you can go to semgrep.live and just use the live editor, or you can do brew install, and we have a Docker repo, so you can try that out as well. But Semgrep's easy way to match interesting code patterns is very fast. We target about 100,000 lines of code per second, so it can run inside your editor. Shouldn't be able to slow you down, but of course we're always making performance improvements, and it works across 5 of the most popular languages that we see, and we're adding new languages every day. Thanks so much.
Awesome. Thank you so much, Drew. Amazing presentation. Thank you for supporting the DEF CON Red Team Village and also Texas Cyber. And for all the attendees out there, please feel free to join the conversation at our Discord servers. You will find the links at the event website, which is in the bottom of your screen.